Okay, now today we will see the electric field intensity due to a thin infinite plane sheet of charge. It is also one of the application of what is a Gauss theorem. Now, so I want to find out, that is a electric field intensity due to a thin infinite plane sheet of charge. So I am taking an infinite plane sheet. Okay. 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 And it is going like this. It is an infinite plane sheet of charge. Okay. Okay, now here the charges are uniformly distributed. Default will take a positive charge. Okay. After we'll see what happens when negative charge is there. That's it. Okay. So this is this is going on both the sides. It is an infinite plane sheet of charge, right? Now what I want is I want to find out the electric field intensity at this point. Let me take this is my point of interest. I want to find out the electric field intensity here. Okay. Therefore, which is at a distance, that is r from the distance from center of here, from here. What is the distance? Distance is the distance from the sheet here. This is r. Okay, right. Now I need to find out the electric field intensity at P. So by using Gauss theorem. So by Gauss theorem is definitely I want a Gaussian surface. Okay. Therefore, how to find out what is a Gaussian surface? Here the Gaussian surface is a cylinder. Okay. I imagine a cylinder of cross-sectional area ds. Okay. And around and whose end surface, one of the end surface P is lying like that. Okay. And it is a cylinder, and what actually it pierces through? It pierces through what? This is the cylindrical surface. Okay. And so that it is, this pierces through our surface, that is charge sheet, like that. And it is a cylinder having whose length is, that is equal to 2r. Length of the cylinder is 2r. I think, hope you are following here. This is here, and okay. Okay, so it is actually this is what is a Gaussian surface? P is a point of interest where we have to find out the electric field, right? Now, what is the best Gaussian surface here? I am considering a cylinder, and cylinder such that, what is the length of the cylinder? Length of the cylinder is 2r. 2r. And what is the cross-sectional area? Cross-section is here, it is ds. Cross-section of the cylinder is ds. Okay, so this is my Gaussian surface. So that, see, actually it is piercing through the Gaussian surface. The cylinder is piercing through the sheet of charge, and it goes to the other side also. Okay, right. Therefore, now by symmetry, if you see, no, the electric field to the right of the sheet should be in this direction. Okay, electric field to the right of the plane sheet should be in this direction, E. Okay, electric field. And to the left, it should be in this direction. Electric field should be in this direction. And what do you say about this is the direction. And what do you say about the magnitude? By symmetry, I am telling, as by symmetry, the electric field magnitude of the electric field intensity will be the same. Okay, it will be the same at if the points are at the same distance, at an equidistance from the sheet. Therefore, what is that? If the distance, all the points here, see, I am telling, all the points here, if you take any point in this line, dotted line, all the points are in the same distance from the sheet. Therefore, they should have the same electric field. Actually, by symmetry, like that. If you take here also, here this is electric field, okay, the direction of electric, okay. And if you take at the same distance, if you take one more line here, here also, what is that? The electric field intensity, the magnitude should be the same. Why? Because they are all the points which are equidistant from the plane sheet of charge should have the same electric field intensity, because this, it is a presumption that it is. Why? Because by symmetry, I am telling, I have not calculated anything, but by symmetry you can say like this, right? Okay, so the electric field to the right will be, electric field direction to the right of the sheet will be towards the right, and to the left of the sheet, plane sheet should be, direction should be towards the left. So this is about the direction of the electric field, right? Now what I want, see, our job is, see, now my what is a Gaussian surface is ready. This is the direction of E, correct? This is the direction of E, right? Okay, therefore, now, see, if you take the curved, so this is curved surface with this surface, top and bottom. Somebody asked the doubt, no? This is the curved surface. And this is your, what is that, end surface, that is edges. Okay, so, if you take the curved surface here, this is the curved surface. Okay, therefore, if you take a small, or on that, if you take a small ds here, a small, in the same, this area is there, no? Same area, if I take here, what will be the area vector direction? Area vector will be normal to this. This will be your n. This will be your n. But what is the direction of the electric field? Electric field here, you see, what is that? Contribution. See, contribution to electric flux by the curved surface, by the curved surface, okay, is given by, that is equal to, what is that? Here E, and E is in this direction, and but n will be perpendicular, that is ds will be perpendicular. Therefore, it is E dot ds, that is equal to E, okay, and ds cos 90. Why? That is E is perpendicular to unit vector, that is area vector. Are you following? Therefore, therefore E ds cos 90, therefore that is equal to 0. Therefore, this is equal to 0. So, there is no contribution to electric flux by the curved surface. If you take the surface here also, here also same thing. If you take here, bottom, that time also, what is the ds here? ds will be in this direction. N will be in this direction. So, whatever be the, if you take any point on the curved surface, there is no contribution to electric flux. Okay. Now, which is left to now? That's edges. Edges. Let me give some name to it. AB. Okay. At the edges A and B, there is this surface is there now. See, let me highlight with this surface is there now. Okay. Here, what is the area vector? This will be your n. Correct? And if you take at A, this cross section, see here at the edge face, what will be the area vector? This is area vector. Okay. Therefore, if you see at A and B, E and electric field is what is the at B electric field will be towards the right, and area vector will also be towards the right, and at A electric field will be towards the left. Area vector is also towards the left. Here also it is ds na. Okay, therefore now I can write, there are two, this surface A and B. Okay, both the what is that edges, okay, both these edges are contributing to electric flux, correct? Therefore contribution to electric flux by the end surfaces, or that is by the edges. Okay, that is nothing but, okay, how many it is? Here also E and N are in the same direction. Don't see, here it is towards right, here it is towards left, A towards left, B towards right. That is okay. But you see whether E and D, what is the direction? E and DS both are in the same direction. Okay, at A both are towards left and at B both are towards right. Both are giving contribution to electric flux, right? Therefore, I can write this one as the two surfaces here. Therefore, 2, okay, E dot N ds. Are you following? Okay, therefore, what that is N ds means that is nothing but ds vector, right? Therefore, that is nothing but E dot N, both are in the same direction. Here this side also A and B, dono side mein E and ds are in the same direction. Therefore you will be getting here as 2E ds. 2E ds. Are you following? Therefore now this is your net flux. Therefore, what is the total flux here? Therefore, what is the total flux? Total flux here is nothing but, therefore, okay, total electric flux. Total electric flux, okay, over the entire surface of the cylinder. Entire surface of cylinder. That is nothing but curved surface, no contribution. Therefore, that should be equal to E, 2E into E ds. Fine. That should be equal to 2 into E ds. Is it clear? Right. Therefore, I have idea about what is the net electric flux. Now we will go for, what is that? Gauss theorem. Okay, therefore, by applying Gauss theorem now. Applying Gauss theorem. Applying Gauss theorem. What is that? Flux phi E. That is equal to 2E ds. Okay, and that is equal to, what is that total? Q by epsilon naught. Q by epsilon naught. This you know now. But what is Q here? What is it? See here, the if you see, let me draw, try to see. Here is the surface na, infinite plane sheet na. Here this is ds is piercing through that. Okay, and here also, right? Therefore, how many, and once more very important thing, this is here, what here the charges are distributed on the surface and uniformly distributed. Therefore, let sigma be the surface, let sigma be the surface charge density. Charge density of the sheet. Okay, therefore, our Gaussian surface is there. Now, our Gaussian surface is enclosing only this many charges. whatever is the charge, let me highlight here. Whatever is the charge here, that is only enclosed by our Gaussian surface. And this side, nothing is enclosed. Only this, how many charges are here, only is enclosed. Therefore, I think this Q by epsilon naught can also be written as in terms of sigma. It is sigma ds by epsilon naught. Kar sakte hai na? Q. Q is, what is Q? Q is the charge enclosed by the cylinder. This side there is no charge, this side there is no charge. Only charge is only when it is piercing that area, only it is enclosing the charge. Therefore, what is the surface area of this one? That is ds. Total charge ke isme kitna hai? Therefore, total charge has to be, the total charge here is Q. Therefore, what is Q? Q, total charge that is enclosed by the cylinder is Q. That is nothing but sigma into ds. Are you following? Therefore, you will be getting, therefore 2E ds, that is equal to sigma ds by epsilon naught. Therefore, ds will cancel. Therefore, what is your E? Electric field intensity is equal to sigma by 2 epsilon naught. E, that is equal to sigma by 2 epsilon naught. Very, very important result. So, that shows that E is independent of R. What is the distance here? Distance is here is R, here is R, na. Therefore, therefore R is not at all here in the expression. E is equal to sigma by 2 epsilon naught. Which says that, okay, the electric flux E is not electric field, electric field intensity is independent of R. Okay, what is R? R is nothing but the distance of the point. That is, R means what is that? It is the distance of the point, distance of the point from the sheet. Are you following? So, it is independent of R. So, now, therefore, if the sheet is not very, it is infinite, no, it is not an infinite sheet, okay, but a large sheet. It is not infinite, but it is large, okay. In that case, so what this expression sigma by 2 epsilon naught, okay, that is valid, okay, in the middle region only. If it's a finite size, it is large, but it is finite size. Therefore, that will be here. It is going dono side mein, it is infinite. But now special case, what is if it is not infinite? It is not infinite, but it is large. In that case, it has some, what is that, size. Okay, it is not infinite size. Therefore, large size. In that case, this expression of E is equal to sigma by 2 epsilon naught, okay, is approximately true in the middle region of the sheet. The middle region of the sheet, away from both the ends, away from both the what is that, both the sides, but and distance also not very much far. You know that it is independent. E is independent of what is that, distance, but if it is, it won't go up to infinity, no? So only this is valid, only the distance is not very much far away from the sheet, not very much far away. If it is at a very large distance, how can you say that what is that electric field will be there? Okay, so the distance is not far, not that much far from the sheet, only then it is valid. Are you following? Right. Now, hope you are following. Okay, this is a case when, what is that, it is not infinite sheet, but it is large. Therefore, this expression is true only, what is it, in the middle region, okay, in the middle region of the sheet, away from both the, on both the sides, okay, and our distance is not very much far away from the sheet. Okay, right. Now, so this is if now, okay, sheet is, what is a, if the sheet carries you can say positive charge. Now what we have discussed already now, okay, that is sigma is more what is greater than 0. Then you can say electric field here sigma E is equal to sigma by 2 epsilon naught होने क्या होता है? E is independent of R and it is on both the side electric field is uniform, correct? Why? Sigma by 2 sigma is a constant. Sigma is nothing but what is that? Surface charge density and epsilon naught 2 everything is constant. Therefore electric field intensity, magnitude of electric field intensity is same at every point. The electric field is uniform. Okay, right, very important. Therefore sigma is larger than 0. The electric field what is that? The electric field is uniform okay, and what is the along, in which direction? And the uniform, you can say normal, okay, and outwards from the sheet, correct? What is the direction of the electric field? Electric field is in this direction only, here, and here also electric field will be in this direction, correct? Therefore on both the side it will be what is a normal to the sheet. Electric field is normal to the sheet, okay, and electric field is that is the direction, and the magnitude is also same, that is E is equal to sigma by 2 epsilon naught. Okay, right. If next one, if the sheet carries negative charge, okay, if it carries negative charge, sigma is less than 0. Sigma is less than 0 means, let me here see, once again I'll draw here, see here, okay, here, here charge is negative here, okay, therefore in which way, what will be the direction of the electric field here? It will be inward, If I keep immediately electric field, how to find out the direction? Just keep a unit positive charge there, in which direction it moves. Therefore, it definitely will be attracted. Therefore, this is the electric field, and here also this will be the electric field. Right? Are you following? If it is charge is negative charge is there means, okay. Therefore, now electric field is, once again it is electric field is normal. Electric field, okay, is uniform, definitely uniform, okay, and okay, inward nor in what is that? It is along, okay, the inward normal and inwards, okay, are the same method, same way I will write here, okay, normal. Let me write like this because there I have, okay. So what is that? Uniform, normal, and inwards, okay, and it is inwards. What is that? That is towards the sheet. Inwards means what is that? It is towards the sheet. Hope you are following. Is it clear? Okay, so this is about what is that? Electric field intensity due to a thin infinite plane sheet of